Yes, welcome. Today we are going to be looking at theoretical probability. We are going to be looking at what? Theoretical probability. In the last time, our probability was all about experimental trial, is it not? We went into the class, we counted the number of people that had over 60% in a maths test, is it not? Or we opened a bar, we counted the number of balls that are good and the ones that are bad, isn't it? In theoretical probability, we have objects that will know the physical state. We know the what? Physical state, like a coin. Every coin has a head or a what? Tail. Every coin has what? Head or a tail. The head is where you see the face of Tafawa Balewa or Abubakar or anybody. The tail is where you have the coat of Nigeria coat of arms, isn't it? Head or tail. Now, every dice, do you know the one they call dice? That you use in playing Ludo, is it not? Every die has how many sides? 6. You have the side that has 1, the one that has 2, the one that has 3 to 6, isn't it? So your probability calculation is based on the state. It's based on the physical state of the object. It's based on the what? Good. So for such, we are going to give an example. 3 coins are thrown together to find 3 coins are thrown what? Together. Find the probability of 2 heads and 1 tail. 2 heads and what? 3 heads and 2 tails and 1 head. Is that clear? So for a coin, we already know that every coin has head and what? Tail. Head and what? So the maximum outcome that you have for a throwing of only 1 coin will be what? Head and tail, which is 2. For throwing 2 coins, you have another head and tail and another head and tail, isn't it? Making the outcomes to be what? 4. But for now, we are having how many coins? 3. So we are going to still have another head and tail, head and tail, head and tail, head and tail, following from the ones that you've drawn before, making the maximum outcome to be what? 8. Is that clear? So how do you do it? Depending on the number of coins that you are told, you will now start. The first coin is going to have head and tail, isn't it? From this first coin, because you have another coin, it's going to have another head and tail, isn't it? And this one is going to have head and tail too. But if you have another coin, making it 3, you still draw again, head and tail, head and tail, head and tail for each of them that you've drawn before. Is that clear? Then when you finish, you pick it out. You're picking for this man now. You're picking for which man? This very one. So you trace it back. You're having what? Head, head, tail. Head, 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 isn't it? Head, head, head. For this person, you trace it back. You're having head, head, tail, isn't it? For this person, you trace it. You have head, tail, head, isn't it? Head, tail, head. For this person, you trace it. Head, tail, tail, isn't it? For this person, you trace it. Head, tail, head, head, isn't it? Down like that. Is that clear? So if you're asked now, what is the total possible outcome? 1, 2, 3, 4, 5, 6, 7, 8. Can you see it? From this, there are 8 what possible outcomes. Is it? So what is the probability of finding 2 heads? You come and check the ones that have 2 heads. This is 2 head 1, this is 2 head 2, and this is 2 head 3. So it's going to be what? 3 over what? 8. Probability of finding 3 heads. What are the ones that have 3 heads? Only this one, isn't it? So the probability will be what? 1 over what? 8. Probability of having 2 tails and 1 head. Then we have 2 tails. This is 2 tails and 1 head 1, 2 tails and 1 head 2. 2 tails and 1 head, 3. So it's going to be what? 3 over 8. Is that clear? So it's as simple as that. And now we're going to check out another example. And the example says a bag contains 2 black balls, 3 red balls, and 6 what? White balls. A ball is picked from at random from the bag. What is the probability of it being black, being red, being white, not red, not black? What is the total possible outcomes for this? It's going to be what? 2 plus 3 plus 6 balls, giving us what? 11 balls. So if you are told to calculate the probability of getting a black, it will come and check how many black do we have? 2. It's going to be 2 over what? 11. The probability of getting a red is going to be 3 over what? 11. The probability of getting a white is going to be what? 6 over what? 11. Probability of getting not red will be the ones that are not red are what? Black and white, which is what? 2 plus 6 all over 11, 8 over 11. And the probability of getting not black will be, we'll take the ones that are not black, 3 and 6 all over 11. Is that clear? Note that the probability of not red is also the same thing as saying 1 minus the probability of red. Is that clear? And the probability of not black is also 1 minus the probability of black. Are we together on that? So we can simply solve the number 2 question. We can simply do what? Solve the number 2 what? Question. So how are we going to solve it? How are we going to solve it? We are going to simply say that the probability of getting what? Black. Is it? Is equal to what? The total number of black, which is what? 2 all over the total possible outcome, which is what? 11. Probability of getting red is the total number of red, which is what? 3 all over possible outcome. Probability of getting white is the total number of white, which is what? 6 all over possible outcome. Probability of getting not red will be equal to what? 1 minus probability of getting red. And probability of getting not black is also equal to what? 1 minus probability of getting what? Black. You solve down. Is that? Or you can say it's equal to the other probabilities. Probability of not red. Not red is what? 6 and 2. You have 6 plus 2 over 11. Is it? Or you can also say that this one is also not black. The ones that are not black is 3 and 6. But 3 plus 6 over 11. So that you can simply give us 8 over what? 11 and what? 9 over what? 11. This will also give us, when we do 1 minus 3 over 11, it will still give us 8 over 11. And when we do 1 minus 2 over 11, it will still give us 9 over 11. Is that clear? Please, if you like these lectures, click on the subscribe button, share these our videos. Thank you. Yes.